Hello, everybody. Good morning, good afternoon, good evening, whatever the case may be for you. Um, this is video number 8, and this homework assignment was on the last section of chapter 4. So we have finished 3 and 4. Therefore, on Friday, this coming Friday, I will give you your second test on chapters 3 and 4. Remember, I told you the first several chapters, I will give you a chapter or a test for probably every 2 chapters. And as we get later into the text, the chapters get longer and there's much more info, and I will give you single chapter tests. But Friday, this coming Friday, I will bring in the chapter 3-4 test for you. Okay? On last Friday, we talked, this section that you had homework on was about slopes. And again, slope, you're going to use the you're going to see the little letter M, and it is the change in y over the change in x. Change in y is vertical movement, change in x is horizontal movement. So it's rise, up and down, over run, right, left. And the most common that you're going to see is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, where x1, y1, x2, y2 are the coordinates of any 2 points on the line. The slope of the line, it doesn't matter how far apart you pick your 2 points or how close together you pick your 2 points, if you can get the x and y coordinates of those 2 points, the slope of the line, y2 minus y1 over x2 minus x1. Be careful the way you subtract. If you put, it doesn't matter which point you label as x1, y1 or x2, y2, but when you do your subtraction, it has to be in order. y2 goes first on top. That means x sub 2 goes first on bottom. Or what you'll do is you'll get the correct number, wrong sign. If it's supposed to be positive, you'll get negative, and vice versa. And also, we talked about this. On a coordinate plane, there's only 4 things that can occur with a line. From left to right, the line goes up. The slope, m, has to be positive, greater than 0. So if you have a line that's going from left to right, going up, and you compute the slope and you get a negative number, you've made a sign error. Likewise, if it goes down from left to right, the slope has to be less than 0. It has to be negative. So again, if you have a line that goes down from left to right and you compute the slope and you get a positive number, you've made a mistake. You've made a sign error. You've subtracted wrong. The slope has to be negative if the line goes down from left to right. And again, you read a graph just like you read English. You go from left to right. So from left to right, this line's going up. Slope has to be positive. From left to right, this line goes down. Slope has to be negative. The only other 2 cases, a horizontal line. If you have a line parallel to the x-axis, it's called a horizontal line. The slope of a horizontal line is equal to 0. And the reason, every point on a horizontal line has the same y coordinate. Therefore, y2 and y1 are the same numbers, and your numerator of your formula for slope will be 0. 0 divided by any non-zero number is 0. The last case, if you have a vertical line is parallel to the y-axis, and a vertical line is said to have no slope. It's undefined because on a vertical line, all of the x coordinates are the same, which means that when you do your slope formula, your denominator will be 0 because the x coordinates will be the same, and you can never divide any number by 0. We talked about that the other day. I explained why. Okay, and then we got a couple of parallel lines have equal slope, with one exception, if you have 2 horizontal lines. Excuse me, I take that back. Parallel lines have equal slope, with one exception, if you have vertical lines. this line and that line. They are parallel, but this one doesn't have a slope, that one doesn't have a slope. You can't say, oh, no slope equals no slope. They don't exist. So the only two lines that we don't talk about parallel lines having equal slope is two vertical lines. Two vertical lines are parallel, but since neither of them has a slope, you can't say their slopes are equal. And this flips around too. If two lines have the same slope, then the two lines must be parallel, and perpendicular lines parallel lines, slopes are negative reciprocals. Turn the slope over and negate it. So if it's positive, the negative reciprocal means you turn it over, and then a negative of a negative, it becomes positive. Again, with one exception. Every vertical and horizontal line, if you get a line parallel to the two axes, if I drew this line and this line, they are perpendicular. But this slope is 0, and this has no slope. So that's the only set of perpendicular lines where the slopes are not negative reciprocals. You can't say the negative reciprocal of no slope is 0. Doesn't make sense. And you can turn that around. If two lines have slopes that are negative reciprocals, the only way that can occur is if they are perpendicular. So that's all the stuff you needed for last night's homework, or for the homework from this section. So homework was on page 202. Page 202, number 4. Number 4 said you were given this figure, and you were told 2, 7, you were given point E is the 0.27, point F is the 0.43. It's not to scale, don't worry, it's just a visual aid, and H. And they said if F is a right angle, find the slope of FH. If that's a right angle, it means these two line segments have to be perpendicular. Therefore, the slope of this and the slope of that, since they're perpendicular, have to be negative reciprocals. Well, I can find the slope of EF. I've got both 2 points. Little m in front of this means slope of the line segment EF. The slope is change in y. And again, be careful. It doesn't matter which point you pick as x1, y1, or x2, y2. So I'm going to say, let this be x1, y1. That's x2, y2. 3 minus 7. Since I used the 3 first, I have to use the 4. The big mistake with slope, you'll go 3 minus 7 over 2 minus 4. You'll get the wrong sign. And this line's going down from left to right. I better get a negative number. 3 minus 7 over 2 minus 4. So the slope is negative 4 halves. Negative 3 minus 7. Did I write this correctly? 2, 7, 4, 3. 3 minus 7. See, I did exactly what I told you not to do. 3 minus 7 over 4 minus 2. Be careful of the way you subtract. 3 minus 7 is negative 4. 4 minus 2 is 2. The slope is negative 2. The slope of EF. And again, I knew I had to get a negative number because from left to right, it's going down. They wanted the slope of FH. I don't even need to know what point H's coordinates are. Because these two segments are perpendicular, the slopes are negative reciprocals. Therefore, the slope of FH is going to be the negative reciprocal of negative 2. Negative 2 is the same as negative 2 over 1. If you turn that over, you get 1 over 2. and you have to negate it. A negative of a negative is a positive. Therefore, the slope of FH is positive 1/2. Positive 1/2. Okay? Number 5. Again, they gave you a diagram. And it's not going to be to scale. It doesn't matter. It's just a visual aid. All right. B, C, D, E, A. All right, they gave you this figure. They told you AD is a median. You had to remember what a median was. A line segment from a vertex to the midpoint of the opposite side. So D is the midpoint of segment BE. And they told you that AC was an altitude. An altitude is a line segment from a vertex to perpendicular to the opposite side. So I know that's perpendicular. That's a right angle. So segment AC and BE are perpendicular. And they gave you the coordinates 5, 9. This is 5, 9. 3, 1 is B, and D is 11, 3. Okay? They first said, find the slope of BE. The slope of BE. B and E. Change in Y. So again, it doesn't matter which point you call x1, y1 or x2, y2. Let's make this x1, y1. That's x2, y2. So it's y2 minus y1, 3 minus 1 over 11 minus 3. So you get 2/8. Always reduce fractions to lowest terms. The slope of BE is 1/4. Slope of BE is 1/4. That's A. B, find the slope of AC. And again, I don't even need to know what point C has as its coordinates because AC is perpendicular to BE. I just found the slope of BE. Therefore, the slope of AC, it's the negative reciprocal. The negative reciprocal of positive 1/4 is negative 4/1 or negative 4. And again, the reason this line and this line are perpendicular, therefore their slopes are negative reciprocals. Part C, it said find the slope of AD. All right, find the slope of AD. I'm going to erase this. I don't need these. All right, to find AD, I do in fact have the slope of AD. I do in fact have to find the coordinates of D. And I'm going to do that because you were told AD is a median, making point D the midpoint of line segment BE. So you had to use your midpoint formula. Average of the x's, average of the y's. 11 plus 3 is 14 over 2 is 7. 3 plus 1 is 4. Divided by 2 is 2. Therefore, the coordinates of point D, 7, 2. And then the slope of AD. The slope of AD. Change in y over change in x. Again, it doesn't matter which point you call x1, y1, x2, y2. I'm going to call that one x1, y1. That's x2, y2. So it's 2 minus 9 over 7 minus 5. 2 minus 9 is negative 7 over 7 minus 5, which is 2. The slope of AD is negative 7/2. And remember, negative 7/2 can be written negative 7 over 2, or minus 7 over positive 2, or 7 over negative 2, or you can make all three signs negative. I showed you that the other day. Doesn't matter which way you write it. They're all the same, negative 7/2. then the last part, it said a line through A parallel to BE. All right. They said, what would be the slope of a line through point A parallel to BE? So if I drew it this way. Well, we said that in part A, the slope of BE was -1/4. So if I call this line L, the slope of line L is parallel to BE, therefore slopes are equal. Lines that are parallel have equal slopes, so the answer to the last one, 1/4. Parallel lines have equal slopes. So I don't need to know any other points. I know for a fact that BE had a slope of 1/4, part A, and any line parallel to BE will have the same slope, 1/4. Okay? Moving on. Again, like I always say, if you ever have any questions, either write them down and bring them in on Friday. Oops, sorry. Or give me a call or email me. All right, problem number 6. Problem number 6 said AB has a slope of 2.5. And I would highly recommend that you write that as a top-heavy fraction. 2.5 is 5 halves. Hopefully you remember how to change. 2 times 2 is 4, plus 1 is 5. That gives you the numerator over the fraction's denominator, 5 halves. The slope is 5 halves. And the question then said, if point A is the point 27 and point B is the point 12K. Find the value of K. Well, again, use your slope formula. The slope of AB is change in y, K minus 7, over 12 minus 2. Well, that gives me K minus 7 over 12 minus 2 is 10. And what do I want K minus 7 over 10 to be? 5 halves. They told you the slope was 5 halves. So you want that to equal 5 halves. And now I just have, hopefully remember how to work. When you have a fraction equaling a fraction, you cross multiply. Product of the means and product of the extremes have to be the same. Just cross multiply. So you get 2 times the quantity, K minus 7, 2K minus 14 is equal to 10 times 5, which is 50. So 2K is equal to 64. K would equal 32. K has to equal 32 in order for the slope of AB to be 5 halves. So again, you put it into the slope formula. I have an unknown variable here, K. Once I get my equation right here, cross multiply. Anytime you have fractions on both sides of an equation, you can cross multiply. We'll actually talk more about this later in the book, but you should have done that in algebra. Okay, that's number 6. The next problem was problem number 8. And problem number 8, they gave you this figure. Again, it's not going to be to scale. Don't worry about it. They told you that RECT. They said the point -2, 1. This is the point -3, 4. Point C was the point 9, 8. And point E was the point 10, 5. Okay, and they said that RE is parallel to TC, or is RE parallel to TC? Is RE parallel to TC? In order to find out if they're parallel, you have to compute the slopes. If the slopes are equal, then they're parallel. So first I compute the slope of RE. The slope of RE, again, it doesn't matter. Call that x1, y1, that x2, y2, or flip it. Just be careful that when you do your subtraction, you subtract in the right order. So I'm going to call this x1, y1, that's x2, y2. The slope of RE is 5 minus 1 over 10 minus, be careful here, 10 minus a minus 2. Please don't drop the sign. So I get 5 minus 1 is 4. 10 minus a minus 2 is 10 plus 2, or 12. Always reduce to lowest terms. The slope of RE is 1/3. Then I have to compute the slope of TC. The slope of TC, again, call that x1, y1, that x2, y2 for this line. So I'm going to go 8 minus 4 over 9 minus, again, be careful, minus a minus 3. 8 minus 4 is 4. 9 plus 3 is 12. 1/3. Therefore, I can in fact say RE is parallel to TC. They're parallel because they have equal slopes. Lines that have equal slopes are parallel. That's part A. Part B for number 9 or 8 is TR parallel to CE? So you're going to do the same thing for part B. Find the slope of each line. If they're the same, then they're going to be parallel. So the slope of TR, using these 2 points, 4 minus 1 over negative 3 minus a minus 2. 4 minus 1 is 3. Negative 3 minus a minus is negative 3 plus 2, which is negative 1. 3 over negative 1 is the same as just saying negative 3. If you want to leave it that way, fine. But the slope of TR is negative 3. CE, the slope of CE. 8 minus 5 over 9 minus 10. 8 minus 5 is 3. 9 minus 10 is negative 1. Negative 3. They have the same slope. Therefore, I can in fact say that TR is parallel to CE. They have the same slope. Parallel lines always have the same slope. And part C, it said show that angle R, this angle R, is a right angle. All right. Hopefully it's on your paper, but we said that the slope of TR was equal to was a negative 3, and the slope of RE in part A, the slope of RE was 1/3. 1/3 and negative 3 are negative reciprocals. If you turn 1/3 over and negate it, you get negative 3. Negative 3 over 1, turn it over, you get 1 over negative 3, and negate it, you get positive 1/3. These numbers are negative reciprocals, therefore TR is perpendicular to RE because their slopes are negative reciprocals, and the definition, lines are perpendicular if they intersect at right angles. So TR is in fact perpendicular to RE. Their slopes are negative reciprocals. Actually, you could say that about every angle. These all four are going to end up being right angles because the two lines always intersect and their slopes are negative reciprocals. The slope of these two lines were positive 1/3. The slope of these two lines were negative 3. Or excuse me, the slope of these two lines were negative 3 and this, or 1/3, RE and TC had a slope of 1/3. These two lines had a slope of negative 3. So everywhere these two segments intersect, the slopes are negative reciprocals. So this, in fact, would have all four right angles, which hopefully somebody at some point has told you that will be a rectangle. We'll talk about those figures later. Number 10. Number 10 said, are the following 3 points collinear? This one you had to use a little bit of thinking power. The 3 points are negative 6, 5, 1, 7, and the third point is 15, 10. Somewhere up here. Now, if they're collinear, that means if I join them, they're on the same straight line. I told you that the slope of a line is found by picking any 2 points on the line and then using your formula, change in y over change in x. So if these 3 points are collinear, that means the slope of the line between any two of them has to be the same number. So if I call that A, B, and C, the slope of AB has to be the same as the slope of BC, which would have to be the same as the slope of AC. Any 2 points you pick, if you compute the slope between them and you get the same number, that means the points are collinear. So I'm going to compute the slope of AB and the slope of BC. Or you could have found the slope of AC. Since there are 3 different points there, you can pick those two, or those two. Let's do all 3 and see what happens. All right, the slope of AB, 7 minus 5 over 1 minus a minus. 1 minus a minus is plus 6. 7 minus 5 is 2 sevenths. So the slope of AB is 2 sevenths. From B to C, 10 minus 7 over 15 minus 1. 10 minus 7 is 3. 15 minus 1 is 14. 3/14. They're not equal, which means these points are not collinear. And let's just pick out the third point. Let's pick out the third point, AC. Let's see if that's the same. 10 minus 5 over 15 minus a minus or plus 6. Negative 10 minus 5 is, or 10 minus 5 is a 5. 15 plus 6 is 21. So you get 3 different slopes. The slope of these two is different than the slope between those two, which is different than the slope of BC. So no is your answer. The points are not collinear. No 2 point, the 3 points do not lie on the same straight line. Again, in order for points to be collinear, the slopes between any two of them have to be the same. So part A, no. Part B, I'm not going to draw it up, I'm just going to list the points. Same problem, different points. So the 3 points they gave you in part B, 7420, 50, 16, and 2/8. And again, let's call that point A, B, and C. So, what we just said in the first part, let's find the slope from A to B. All right, the slope of AB. 20 minus 16 over 74 minus 50. 20 minus 16 is 4. 74 minus 50 is 16. You get 1/4. All right. I take that back. 74 minus 50 is 24. You get 1/6. Did that on purpose. All right. Let's find the slope of BC. If you get the same number, the lines, the points are collinear. They're on the same straight line. So BC, 16 minus 8 over 50 minus 2. 16 minus 8 is 8 over 48, which is 1/6. The points are collinear. To make sure, let's find the slope of AC. It has to be equal to 1/6 also. If they are in fact collinear, 20 minus 8 over 74 minus 2. 20 minus 8 is 12 over 72, which is reduced to 1/6. The slope between any two of those 3 points is the same exact number, 1/6. Therefore, the points are collinear. The only way they could in fact have the same slopes is if they're on the same straight line. So the answer to this one is yes. They are collinear. Okay? Everybody good with that, hopefully. Last problem, problem number 13. And in problem number 13, it said they gave you 3 points. A is the point 611. B was the point 15. And C was the point 17,0. Or excuse me, 70. And they said show by means of slopes that the triangle ABC is a right triangle. Well, in order to have a right, I'm not going to even, you don't even need to sketch the, you don't even need to draw a sketch. All you need to do is use slopes, because if I find the slopes of the 3 sides of this triangle, AB, BC, and AC, if 2 of them have slopes that are negative reciprocals, then those 2 particular sides are perpendicular. Perpendiculars intersect at right angles, making it a right triangle. So I need to compute the slope of AB, the slope of AC, and the slope of BC. And if the slopes of any 2 of them are negative reciprocals, that makes those sides perpendicular to each other, making it a right triangle. So the slope of AB, 11 minus 5 over 6 minus 1. The slope of, I'll compute it in a second, AC, 11 minus 0 over 6 minus 7. And the slope of BC, 5 minus 0 over 1 minus 7. Too sloppy. So 11 minus 5 is 6. 6 minus 1 is 5, 6/5. Here I get 11 over negative 1, which is negative 11. And here I get 5 over negative 6. Negative 5/6 and positive 6/5 are negative reciprocals. If you turn that over and negate it, you get that. If you turn this over and negate it, you get that. Therefore, that tells me that AB is perpendicular to BC, meaning that angle ABC, if you were to sketch the 3 points, angle ABC is a right angle, making the figure, those 3 points when connected, making it a right triangle. And then they said, and what would be the hypotenuse? The hypotenuse would be the side opposite the right angle. And since the right angle is at B, the vertex B, that makes side AC. If you were to sketch it, side AC would be opposite angle B. AC would be the hypotenuse of the triangle. Okay? Hopefully everybody's got all these. And if there are any questions, again, just write it down or give me a call, send me an email. And that, my friends, is the end of chapter 4. Alrighty, we are going to skip over the first part of chapter 5. And let me digress here for a second. At the end of every chapter, I don't know if you've noticed, but at the end of every chapter, they have review problems or a chapter test. And they also, a really great study guide is the chapter summary at the end of each. They give you bullet points for all of the topics that we talked about, and they tell you where to find it, what section it was in. And also then you're going to have either a chapter test or you're going to have a whole bunch of review problems, which are really a good study guide also. So if you want problems to do, go in there and pull those problems out and see if you can do them. Alrighty, the type of proofs that we have been doing are called direct proofs. A direct proof, you're going to be asked to prove something, and then we're going to do a 2-column deductive proof where we're going to prove exactly what it is that they asked us to prove. So if I had here's the kind of proof that we've been doing. I gave you triangle ABC with AB congruent to BC and BD perpendicular to AC. You'd be asked, a type of problem that you might see is prove that BD is also a median. And we would go through the proof and we would prove triangles congruent, and we could prove that D cuts AC in half. We could prove these two segments are congruent, and then we could conclude BD is a median. That's called a direct proof, where you go through the steps and you directly prove that. There's also something called an indirect proof, which we are not really ever going to do. So I'm not going to spend a lot of time. I'm just going to give you a real quickie intro into it, and that's that. I'm never going to ask you to do an indirect proof. An indirect proof, it's going to look the same, sort of, but what you're going to do is you're going to look at the statement you're going to try to prove. Well, there's only two options here. Either BD is a median or BD is not a median. Those are the only two options. Either it is a median or it isn't. An indirect proof, we're not going to prove that it is a median. We're going to prove the other option is not a median, doesn't work, it's false. So you list all possible options and you show that the option that you show all the other options don't work, therefore whatever it is you wanted to prove does work. And you do that by getting a contradiction. And again, we're not going to really use this. It's kind of interesting, but rarely, if ever, are you going to do indirect proofs. But that's what an indirect proof would look like. You would write, well, BD is a median or it's not. And you would show that it's not doesn't work, therefore it would have to be a median. That's an indirect proof. You don't prove this directly, you prove that the other options don't work. And the only reason that they introduce this is because these next sets of theorems that we're going to get right now can only be proven indirectly. And the first one is, all right, if I have triangle ABC, whenever you have any kind of triangle, all right, angle A, angle B, and angle BCA are the angles of the triangle. If you extend a side of a triangle, you have formed a new angle outside the triangle. This is called an exterior angle. And I could extend the side this way, and I would have the exterior angle. I could extend it this side, and I would have an exterior angle over here. I could extend side BC. I would have an exterior angle up here. And if this is the exterior angle that I'm working with, angle A and angle B are called remote interior. They're the two interior angles of the triangle that don't share a vertex with that exterior angle I am working with. In other words, if I extended this side, here's my exterior angle now, and angle A and angle C are the remote interior angles. They're the other two angles of the triangle that don't share a vertex with this exterior angle. So you can go to any vertex and extend the side, you form an exterior angle, and then the other two angles in the triangle, not sharing a vertex, are called remote interior angles. This first theorem that we're going to get, you can abbreviate it EAT, EAT, exterior angle theorem. The exterior angle theorem. Exterior angle theorem says in any triangle, all right, so as drawn, here's my exterior angle, here are my remote interior. And this says the measure of an exterior angle is greater than either remote interior angle. So the exterior angle, call it 3. The exterior angle theorem says 3 is greater than either remote. So 3 is greater than 1, 3 is greater than 2. And that's all this theorem says. And again, the only, I'm not going to go through and prove it. You have to use an indirect proof. And again, we're not going to really use them other than we would use them today to prove these. All you need to know, an exterior angle of any triangle is greater than either remote interior. Okay? EAT. And we're going to improve on EAT at a later date. Now, we're going to talk about how to prove lines are parallel. First, the first one says, if alternate interior angles are congruent, if a set of alternate interior angles are congruent, so if that's congruent to that, the only way that can be the case is if the two lines are parallel. And here we're all talking again on a plane surface. If two lines are cut by a transversal forming a pair of alternate interior angles congruent, then the lines are parallel. And just write it shorthand, use abbreviations, and use symbols. If alternate interior angles congruent, lines are parallel. And again, the only way to actually do this is indirectly, so we're not going to prove it. We're just going to accept it. We're going to use this as a postulate. So here's your first method to get lines parallel. If you have any two lines cut by a transversal forming a pair of alternate interior angles, the lines must be parallel. Second method. Hopefully you remember, 1 and 2 are alternate exterior angles. If alternate exterior angles are congruent, lines are parallel. And you can use the theorem before it to prove this one. 1 and that angle are congruent, 2 and that angle are congruent. Vertical angle theorem, transitive property or substitution makes those two congruent. Therefore, you have just got alternate exterior angles congruent, then lines are parallel. Okay. These are a pair of corresponding angles. If you can get a pair of corresponding angles congruent, then lines are parallel. Again, fairly simple. If those are congruent, well, 1 and this angle are congruent. They're vertical angles, and then I have a pair of alternate interior. So I don't need to go through the whole thing. If I have a pair of corresponding angles congruent, doesn't matter which pair. It could be this pair, that pair, or that pair. If a pair of corresponding angles are congruent, then lines must be parallel. So you now have 3 ways to prove lines parallel. All right, here I've got 2 lines cut by a transversal, and this one says if interior angles on the same side of a transversal are supplements, then the lines are parallel. Interior angles, same side of transversal, are supplements. Lines must be parallel. And this one's fairly simple to prove. If I call this angle 3, so you're given 1 and 2 are supplements. Well, I also know 1 and 3 are supplements. They form a straight line. Then by supplement theorem, that means 3 and 2 are congruent. If 1 is a supplement of 2 and 1 is a supplement of 3, supplement theorem says angle 2 is congruent to angle 3. 2 and 3 are alternate interior, therefore I've got alternate interior angles congruent, lines are parallel. So here's a 4th way to get lines parallel. If a pair of interior angles on the same side of a transversal are supplements, then the lines are parallel, and then the same exact thing, just substitute for interior, exterior. If a pair of exterior angles on the same side of a transversal, 1, 2. These are exterior angles on the same side of the transversal. If they're supplements, then the lines must be parallel. Or excuse me, if a pair of exterior angles on the same side of a transversal, are supplements, then the lines are parallel. And again, just do the following. Call that 3. So we started with 1 is a supplement of 2. Call that angle 3. 1 and 3 are supplements, which then tells me 2 and 3 have to be congruent by supplement theorem. And if 2 and 3 are congruent, these are corresponding angles. And we had a theorem 5 minutes ago. If corresponding angles are congruent, then lines are parallel. So we now have a bunch of different ways of getting lines parallel. And one more way. Line 1 is perpendicular to line 3. Line 2 is perpendicular to line 3. Therefore, and again, these are all coplanar. We're talking about coplanar lines. If two lines are perpendicular to the same line, then these two lines have to be parallel. And actually, you could use almost anything that we just talked about. These are all going to be, since they're perpendicular, these are all right angles. So I've got alternate interior angles congruent. They're both 90. Therefore, the lines are parallel. I could have said a pair of corresponding angles, 90 and 90. Therefore, the lines are parallel. I've got exterior angles on the same side of the transversal, supplementary. That and that are supplementary. They're both right angles. Therefore, the lines are parallel. Everything we talked about prior to this could be used to prove it. So this simply says perpendicular lines perpendicular to the same line are parallel. So there's another way. Lines perpendicular to the same line are parallel. So the difficulty that you're going to have with this stuff is when you have a figure drawn, like here. So if I gave you this figure, and you were told that angle, if I told you this angle is congruent to that angle. By looking at this figure, do I have any lines in this figure or line segments parallel by one of those methods that we just talked about? The answer is yes. And again, you got to creatively think. And if you can't see it, draw something or extend something or make it hopefully a little bit more visible to you so that you can see what you're working with. If you notice, CE, if you extend it, is that line. FB, if you extend it, looks like that. With respect to these two lines, CE and FB, those are alternate exterior angles using AD as the transversal. Again, if you get rid of everything else, if you get rid of this, get rid of this, I now have two lines cut by a transversal. This is a pair of alternate exterior angles. They're on the outside of these two lines, one on opposite sides of the transversal and not sharing a vertex, which tells me that these two lines are parallel. If a pair of alternate exterior angles are congruent, then the lines are parallel. So this is the kind of stuff you're going to have to look for in the problems from this section. They're going to give you drawings, and if you can't see it in the actual drawing, see if by extending something or erasing something, it makes it a little bit more clear what you're trying to work with. And that's all I want to talk about. So, for Friday, please. Okay. Okay, and that's all. Alrighty. Page 220, 4589, 14, 15, 16, 23. Most of these are numerical. There are a couple of proofs, but most of those are numerical. Or they're asking you to find the parallel lines and use the proper cite what you use to get them parallel. So, any questions, please feel free to call or email, or write them down and bring them with you Friday. And I look forward to seeing all your smiling faces on Friday. Have a great week. Bye-bye.